This is the solution to the Swift Language Basics Challenge. For this challenge, we are to create a Mac OS command line application written in Swift called Swift Language Basics. To create a command line application, in Xcode, go to File, New, Project, select Mac OS Command Line Tool, and then enter the product name, which in this case would be Swift Language Basics, and then decide where you're going to save it. I've already created this project and written the application, and I'd saved it in Projects, Mac OS, and then it created the folder for me called Swift Language Basics. So here is the project I created, and it automatically created a Swift file called main.swift, which is the starting execution point for my program. The code in main.swift is going to be the beginning for my program. And this is not the case for iOS. When we do iOS development, we won't really be dealing with this main.swift. But if we're doing a command line application, the start is main.swift. So now let's take a look at the requirements and how to implement them. We are to declare the following constants and variables and set their initial values as indicated. Constants in Swift are declared using the keyword let, and variables in Swift are declared using the keyword var. The first constant that we are to create is an unsigned 8-bit integer named sample1 with an initial value of 0x3a. So here I have the line of code that does that. Let is what we use to declare a constant. It's named sample1. We are explicitly setting the type to an unsigned 8-bit integer, or uint8, and then that's being set equal to 0x3a. And 0x3a is how we represent a hexadecimal value. 0x indicates that the value that follows is going to be in hex, and so our hex value is 3a. An unsigned 8-bit integer can hold values from 0 to 255. 8 bits can have 256 values. Since it's unsigned, it's going to be 0 and positive values. And so 0 through 255 is what we can hold in a single byte, that is in 8 bits, if it's treated as unsigned. Now I need this explicit declaration of the uint8 after sample1, because if I say let sample1 equal 0x3a, it's going to implicitly set the type of sample1 based on the value to the right. And let's see what Swift decided to do with that value. So if I hold the option key down, I get a question mark when I go over my variable. So in this case, constant actually, sample1. If I click on it, it tells me that this is of type int. So implicitly, it looks on the right and sees this, and it thinks, okay, that's an int, and so sample1 is going to be declared as an int. If I want sample1, though, to be an unsigned 8-bit int, then I'm going to need to explicitly declare it as that type and assign this value. Now again, an 8-bit value that's unsigned can hold values between 0 and 255 in decimal, or if we're in hexadecimal, between 0 and FF. And 3A is between 0 and FF, so 3A as a hex value will fit in an 8-bit unsigned integer. The next declaration is a variable, so we say var, named sample2. It is also an unsigned 8-bit integer, and I'm going to set its initial value to 58. That's a decimal value. It is between 0 and 255, so it is a valid unsigned 8-bit integer. If I remove the explicit declaration, like the line above it, sample2 will think that it is an integer by default. So this is an implicit setting of the type, and Swift allows this. We can either set the type explicitly, like where we said sample1 is an unsigned 8-bit integer, or implicitly, because on the right is the number 58. Swift says that looks like an integer, and so it declares sample2 to be an integer. If I need it to be a uint8, then I can explicitly set it to that. Now it turns out that 3a in hex and 58 in decimal are in fact the same value, and if we were to compare them, and we're going to compare them, we'll see that they are in fact the same. Now what if we wanted to know more about the types in Swift, or more about this unsigned 8-bit integer in Swift? If I go to Chrome, I could search for uint8 Swift. The first link that comes up is the Swift standard library, and it says, yes, this is the type for an 8-bit unsigned integer value. And we see all the different ways that we can initialize this. We'll talk more about that in some future sessions. We can also go to the Swift programming language documentation, go to the basics. On that page is a section on integers, and it says that Swift provides signed and unsigned integers in 8, 16, 32, and 64-bit forms. So that's 1 byte, 2 bytes, 4 bytes, and 8 bytes. And it even says here explicitly, these integers follow a naming convention similar to C. An 8-bit unsigned integer is of type uint8, which is what we're using. So we've taken care of declaring the sample1 and sample2. The next is declare a variable of type int named heart rate with an initial value of 85. And this is a variable, so we say var. The variable name is heart rate, and we set it to 85. And remember when we looked at 58, a number like that Swift thinks is an integer, and so implicitly heart rate is an int. So by simply saying var heart rate equals 85, I have done what this requirement states. I have declared a variable of type int called heart rate with a value of 85. I would also be correct if I explicitly said that heart rate was an int. And so if I click on it, we see it also says int that way. So acceptable either way. Here explicitly set to int, or here implicitly set to an int. Next, it says declare a variable of type double, so variable var of type double named deposits that has an initial value of, and that's 135,002,796. Now that number alone does not look like a double. A double has a decimal part, like point something. If I don't explicitly set deposits to double, hold the option key down and click, we see that deposits is implicitly set to a type of int, because this in fact looks like an int. But if I say deposits is a double, and then set it to this value, then deposits is in fact a double. And this is an int, but it's being assigned into a value that can hold that integer value as a double. All of the precision is there. So I need to explicitly say double because the number that I am assigning to deposits itself is not a double. But it will be converted into a double when it's assigned to deposits. The next is to declare a constant float, so it's a float type, named acceleration with an initial value of 9.800. So let makes this a constant, acceleration is the constant name. Float explicitly declares acceleration as a float, and 9.800 is the initial value. Now if I get rid of the explicit declaration of float, then acceleration is going to be a double, because this thing that has a decimal value is already considered by Swift to be a double. So let acceleration equals 9.800 will make acceleration a double, unless I explicitly say that I want this to be a float. And the question is, what's the difference between a double and a float? Difference between double and float. Different level of precision. A double can hold more precision than a float. 9.800 is a low enough precision of a number that it will fit in a float. So 9.800, even though it's a double implicitly, can be assigned acceleration, which has been declared as a type float. Now, before we continue with this, I want you to notice a couple of things. One is there are no semicolons at the end of the lines. Swift doesn't care if you put semicolons, but semicolons are not required on single lines of code, and it is considered bad form to put semicolons at the end of Swift lines. The other thing is, see the pattern here. Let and var, constant and variable. The constant name or the variable name comes next. If you're going to explicitly set the type, it comes after a colon after the variable name, which is different than many languages where the type comes before the variable name. And then we can initialize this value when it's created to hold a particular value. Let's go to the next one. The next one is mass. It is a variable, it's a float, and it should be initialized to 14.6. So variable called mass, explicitly set as a float, and then set to 14.6. Without the float, just like the value above, mass would be implicitly set to a double because Swift takes this value that has a decimal in it and thinks that by default it is a double. But we can explicitly say, no, we want this to be a float. The next value is a variable double distance with an initial value of 129.763001. So variable, var, distance is the name of the variable, and it is being set to this value. And this is to be a double, and by default, values with decimals are doubles. And if I hold Option and click on this, we can see that it is, in fact, a double. The next is that we need to declare a Boolean, a bool, named lost that has an initial value of true. So it is a variable, so we say var, we call it lost, and we set it to true, which is a Boolean. Since that's a Boolean, then the system knows that lost implicitly is a bool. Same thing for expensive. We want a variable bool named expensive, and it has a value of true, so var expensive equal true. Next, an int named choice with an initial value of 2 that's a variable. So we say var choice, and that's set to 2. 2 is an integer, and that means choice is explicitly not set to anything, but implicitly is set to an int. If I want to explicitly make it an int, then I could do this, and Swift is happy either way because either way it's an int. If I explicitly say int, it's an int, and because of the value on the right, I can implicitly say that choice is an int. The next is we have a constant called integral that's of type character, and it has an initial value, this looks kind of funny, in quotes, /u, and then curly braces around 222b. I'll explain what that means here in a second, but let's get the other parts here first. It's declare a constant, so it is let. It's called integral, so we put integral. It is of type character, so I'm going to explicitly set its type as character. And then it's going to be set equal to this quoted thing with a /u curly brace 222b. 222b is the Unicode value for the integral sign. So let's actually go to Google and search for Unicode characters. List of Unicode characters. And then on this page, I'm going to search for math, go to mathematical operators, and right here is the integral sign. And notice in this column it says U plus. This is just another way to represent a Unicode value. U for Unicode, the plus sign followed by a hexadecimal value. And it is 222, and then the X here says that this number at the top is the last value depending on the character. So this whole line are values that are 2220, 2221, 2222. And if I go to the integral, it is 222b. So the Unicode hex value 222b is the integral sign. The way that Swift lets me specify this Unicode character value is /u inside of a quoted string, followed by the Unicode's hex value inside of curly braces. So the 222b inside of curly braces after a /u says that this is going to be this character. The next two are strings. First one is a constant, the second one is a variable. First one is a constant, second one is a variable. The constant is a string named greeting that is the string hello. So we'd say it's a constant, so let greeting equal, and then we're setting it equal to a string. That implicitly is setting greeting to be of type string. And then name is a variable, so var name, Karen in quotes, which means implicitly name is a string. I could explicitly make name a string this way. Either way, name is going to be a string. So that takes care of declaring my constants and variables and setting their initial values. The next step is to use these to answer some questions. And this is to get some experience with various structures, such as control structures and looping structures inside of Swift. So sample 1 and sample 2 are to be compared, and if they are equal, we are to display the samples are equal, and otherwise the samples are not equal. So the way we test the equality of value in Swift is equal. So we say if sample 1 equal sample 2, then we print that the samples are equal. And then else, if we don't have that happen, we would say print, I can grab this from the document, the samples are not equal. So if the samples are equal, we'll get the samples are equal, and if they're not equal, we'll get the samples are not equal. And I previously ran the program, and you can see here the samples are equal. So what I said earlier is in fact true. The hex value 3a is in fact the same as decimal 58. If I open up Google, I could say convert hex 0x3a to decimal. And Google will tell us that 0x3a is decimal 58. It's also binary 111010. So 3a is 58. And we in fact see that those two are the same because we printed out the samples are equal when they are compared. Next, if the heart rate is greater than or equal to 40, so if heart rate greater than equal to 40, and so if we're going to take two logical operations and test if they are both the same, we say ampersand, ampersand, that's the equivalent of and. Heart rate is less than or equal to 80. So if we're greater than or equal to 40, less than or equal to 80, then the heart rate is normal. Otherwise, the heart rate is not normal. So we have an if-else. And the heart rate we listed is 85. That's greater than the 80. And so when we ran the program, we get that the heart rate is not normal. Next, we are going to look at the deposits. So we have here if deposits is greater than or equal to this number, which happens to be 100 million, then we would print you're exceedingly wealthy. Otherwise, we're going to print sorry you are so poor. Now notice this if statement, I didn't put parentheses around the test. I can if I want, but Swift also allows me to do the if without the parentheses around the test, the logical test. And the particular deposit happens to be 135,2,796, which is bigger than the 100 million. So when this is tested, we get you are exceedingly wealthy. Next, we want to declare a variable called force that is assigned to the mass times the acceleration. The force variable must be of the same type as the result from the multiplication of mass and acceleration. Now, both acceleration and mass were declared as floats. So according to that, we also want force to be a float. Now down here I have var force equals mass times acceleration, and I used var because it says declare a variable. Now mass is a float and acceleration is a float, and if we multiply the two floats, we should get a float. So when I declare var, I'm implicitly using the fact that what's on the right is a float to set force to be a float. Now if I wanted it to be explicitly set, I could say that force is a float and it's equal to mass times acceleration. Either of those would be correct, either explicitly set or implicitly set. The next thing we're asked to do is display the calculated force preceded by the string force equals. The output should look like, force equals a number. So this line of code, print force equal. So print is accepting a string. That's this double quoted thing. And this is just the string here, force equal. This, the slash parentheses, a variable name, and then parentheses, will take the value that's in the parentheses and convert it to its string equivalent. So force is a float, but here, because we put slash parentheses around it, it will be interpolated into a string. So this print will print force equals whatever the result of the mass times acceleration is out to the display as a string. So there's the answer we get, force equals 143.08. Anytime you don't really care about the formatting of the value, in terms of like how many decimals are displayed, you can use this technique. If you want to explicitly format the output, then there are other ways to do that. But this is the simplest way to convert a value to a string inside of a string. Next, I want to display the value of distance followed by is the distance. The distance is here. It's a variable. It's a double. And it's really simple to do this. The same way we can say slash parentheses distance inside of the double quoted string. And that will take distance, which is a double, and convert it to a string. So we're going to get 129.763001 is the distance. This is the 129.763001. Next, using lost and expensive, which are bools, display I'm really sorry, I will get the manager if lost and expensive are both true. And here is a coupon for 10% off if lost is true and expensive is false. So if lost and expensive are both true, we can just say if lost, ampersand, ampersand for and, expensive. If true and true, then we print I'm really sorry, I will get the manager. Now the second one said if lost is true, so we just have lost here, and expensive is false. Now I could write expensive equal false. So I could say lost and expensive is false. We got a little red exclamation point here when I did that. Didn't mean to put a breakpoint, so I could delete that breakpoint. I guess it was trying to figure itself out. I could also say, well, let's make sure that this is tested first. So if lost and expensive equals false, so we could do that. That would be fine. But the way that I had it does exactly the same thing. If expensive is false, I can invert that logic by putting the exclamation point, the not, in front of it. And so if expensive is false, putting the exclamation point in front of that makes this true. And if that's true and lost is true, then we're going to print, here's a coupon for 10% off. So I could read this if lost and not expensive. Then we print that statement. Next, use switch case and the variable choice to display you chose 1 if you chose 1, you chose 2 if you chose 2, etc. So switch case, variable in a number of languages, is a little bit different in Swift, which we'll cover here. So you would say switch followed by the thing you want to test, which in this case is choice, and we want to know whether choice is 1, 2, or 3, or if it's none of the above, the default condition. So we say switch choice, curly brace, open, close, and inside of it we have a set of case statements and a default. Case 1 says if choice is 1, then we're going to print you chose 1. Now, in other languages, say like C, you would need a break statement after this print, because without the break, it would automatically fall through to the next case. In the case of Swift, there is no automatic fall through. In fact, if you want to fall through from one case to another, you explicitly must specify that you want to fall through. So here, if we are case 1, it's going to print you chose 1, and this is done. If we're not case 1, then we can test to see if we're case 2. If we are, we'll print you chose 2. Same thing for 3. Now, if it's none of the above, we can set a default. So if it was the case was 0, if it was 4, or if it was 1,000, and we don't have a case for it, then default will catch it. And in that case, we're specifying you made an unknown choice. Now, let's say we didn't have a default. And this default is required because we have here you made an unknown choice if choice is something other than 1, 2, or 3. But let's say we were only told to deal with cases 1, 2, and 3. So I'm going to cut the default line and give it a second, and we get an exclamation point here indicating an error. And when I click on it, it says, switch must be exhaustive. Consider adding a default clause. So why is this? Choice was declared to be a variable that was set to 2. 2 is an integer, and we can see here that it's an int. If it's an int, there's a lot of things that choice could be set to other than 1, 2, or 3. So to make sure that we haven't missed some possibility that gets set on choice, this is telling us that we have to be exhaustive. We have to cover all possible cases for an integer. And we clearly have not covered all the possibilities for an integer. Since I can't list all of the cases, because there's a large number of them, and I'm only interested in cases 1, 2, and 3, then I can be exhaustive by creating a default case that handles the rest of them. So case 1, 2, and 3 handles 1, 2, and 3, and default handles the rest. And I want to remind you one more time that switch case in Swift does not automatically fall through from one case to the other, and therefore breaks are not required inside of each case. Next. It says using the constant integral, which is a character, display the character in the constant integral followed by the string is an integral. So just like when I printed distance up here or force up here, I can use slash parentheses around the variable integral to print what integral is. An integral, remember, is a character. So we're going to need to have this character converted to a string to be displayed inside of whatever it is an integral. So slash parentheses around integral is going to convert the character to a string, interpolate it, whatever that is gets displayed, and then is an integral follows it. And here we have it. And it actually knows here in the terminal how to display that Unicode character. The value 222b as a Unicode value is an integral, and here in my output we see that that is in fact the integral sign, and we're displaying integral is an integral. Next, using a for loop, count from 5 to 10, inclusive, that is include the start and the end, and we want to use an int variable I to do the counting, and then in the loop we want to display I equals followed by the value of I. Now loops, for loops in Swift are different than for loops in some other languages like C. In C I might say for int I equal 5, I less than equal to 10, I increment. In Swift, we use this style of a for to count from 5 to 10 inclusive. So for I in, so we're saying that the for loop should iterate through some set. The set here is 5 through 10, and so the I should be taken from that set. So for I in 5, and then there's ... 10. And the ... is telling us that we should be inclusive of this last value. So we're going to have 5, and then we're going to get 6, 7, 8, 9, 10. And that's because we have 3 dots, the 10 is included. And if we look at the output, we have I equal 5, 6, 7, 8, 9, 10. Now, it said that I is to be an integer. And I didn't explicitly say int, but the set here is a set of integers, and so implicitly I will become an int type. And then to display I equal and then the value of I, we're using that slash parenthesis to interpolate the value I, which is an integer, into a string. And so I equal and then whatever the numerical value is converted to a string and is displayed. And print automatically does a /n at the end, which we've seen already. And so we have I equal 5, I equal 6 through I equal 10. And so we do have an inclusive start and end. Now what if I didn't want to include 10? I could replace that third dot with a less than sign. And now this says that we should start with 5, but we should stop before we reach 10. If I run this, you'll notice we have 5, 6, 7, 8, 9. 10 was not included. This is saying that 10 should be greater than the last number, or the number from the set should be less than 10. So I'm going to set this back to the way it should be for the solution. We want 10 included, so we say 5 ... 10. Again, think of this like this is a set of numbers, and we're going to pull I one at a time out of the set, incrementing through that set, so 5 through 10. Next, we want to declare an int variable age. So we have here var age, and we're initializing it to an initial value of 0. I don't need to explicitly say here int, although I can do that, because 0 is an integer, and if I hold option and click on age, we see that it is of type int. by implicitly setting int based on the value on the right. So I initialize age, which is a variable, to an integer 0. Then using a while loop, so I have here a while, that continues while age is less than 6, age less than 6. And we want to display the age in a line that says age equals followed by the value of age. So we say age equals, and then we use this slash parentheses around the variable to convert the integer age into a string for display in the print. And then it says after the age line is displayed, increment the value of age by 1. And so I did it in this case by saying age plus equal 1. That is the equivalent of saying age equals age plus 1. So I could say age equals age plus 1. I could, as I already did, say age plus equal 1. What I cannot do is I cannot say in Swift age plus plus. Give it a second here. And we get our red dot. Click on it and it says plus plus, the increment operator, is unavailable. It has been removed in Swift 3. It used to be here in Swift, but it was decided for a variety of reasons that it could actually create confusion in code, that the increment operator is not a good idea, and so we do not have the plus plus. And if I click fix it, it will actually rewrite the code like I had it, age plus equal 1, which again is the equivalent of age equals age plus 1. So we take the previous age, add 1, and that becomes the new age. This is saying let's take age and let's replace it with 1 added to it. So the ages, we start with 0, 0, 1, 2, 3, 4, 5. We stop before we reach 6 because age has to stay less than 6, and we're incrementing the age after we print it, so we never actually reach the value 6. And then finally, we are to display a line that contains the greeting string, followed by a space, followed by the name string. And so we are printing, and then we put slash parentheses around greeting, put a space, slash parentheses around name, and we would get, in this case, hello Karen. We get the greeting, a white space, and then Karen. This is not the only way we can do this. In fact, we'll find often in our Swift code that there's more than one way to solve a problem. I could also say print greeting, greeting, and then I need to concatenate to it, so I could use the plus sign, a space, and then concatenate to that the name. And if I run this, we get the same result. We're printing a string, and the string was comprised of the string greeting concatenated with the string, which was a single space, concatenated with name. If we go up here to while age less than 6, can we put parentheses around while age less than 6? Let's run it, make sure that that works, build succeeded, and that continues to work the way we expected. Parentheses, though, are optional around the logical test. So, finally, let's just review the important parts here that should be learned from this exercise. Let is the way you define a constant. Var is the way you define a variable. A constant, once set to a value, cannot be changed. So let's take a look here at let greeting equal hello. That means greeting is set to hello and cannot be changed. If I try to, so let's say I say greeting equals goodbye. Give it a second to think about that. We get a red dot indicating an error. It says, cannot assign to value greeting is a let constant. The only way that this could work is if greeting were a variable, and it's showing it in gray here. I could click this and it would convert the let to a var, and then I could do this. But if I in fact wanted the greeting to be a constant, that means once I set it to hello, it's not meant to change, then I cannot later change the value of greeting. And that's the whole point of making a constant, something constant, is to indicate that it's not to change, that this thing greeting is supposed to be hello and not to be changed later. So var is a variable, let's a constant. If we are explicitly setting types, they come after the variable after a colon. If a type is not explicitly set, it is implicitly set. So like here, 85 is an integer. That implicitly makes heart rate, holding the option key down, clicking, an integer. Values can be represented in multiple ways. This is a hexadecimal value. This is a decimal value. And here we have a Unicode value, which is based on a hexadecimal number, but it is meant to be represented as a character that's Unicode, so we use /u and parentheses around it. And then finally, interpolation or conversion of values into strings can be done using /parentheses. And I'm doing it inside of a print, but we're constructing the string and the string is being handed to print. I could construct any string using this technique. So for example, I could say var message equals, and then I could use this to make a string that contains the greeting and the name. And then if I said print message, it would print that string. So if I run this one final time, we'll see hello Karen 3 times. So here I'm actually constructing the string and then printing it. Here I'm building the string inside the print statement, either by concatenating one string with another string with another string, or by using this /parentheses interpolation of a value to a string. And even if it is a string, I can still use this to do kind of the inclusion of a variable in a string to make a string. And I'm going to remove these last 2. And this is then the same code that is posted for you to download on Canvas.